Hello guys, in this video I'm going to answer a full problem using the limiting and the excess reactant. The problem says, the reaction between solid sodium and iron 3 oxide is one in one series of reactions that inflates an automobile airbag. If 100 grams of sodium and 100 grams of iron 3 oxide are used in this reaction, determine limiting and excess reactant, mass of solid iron produced, and the mass of excess reactant that remains after the reaction is complete. The first thing to do is to analyze the problem, looking for the data. In here, it is important that we identify the 100 grams of sodium, the 100 grams of iron 3 oxide, that we are asked for the limiting and excess reactant, the mass of solid iron produced, and the mass of excess reactant that remains after the reaction. So we write the information in the equation that is already balanced, and we notice that we have two numbers that belong to the knowns, and we are looking for the grams of iron, which would be the unknown. So as you can see, we're following the same pattern as always. After this, we would start calculating the limiting and excess reactant, where we need to start changing the grams to moles. So we start 100 grams of sodium, then we would write the parentheses with the fraction, and we would end with moles of sodium. The second one would be 100 grams of iron 3 oxide, then we would write the parentheses of the fraction, and we would end with moles of iron 3 oxide. Remember that down in the fraction, we're going to write the unit and the compound that belong to the known, and in the upper part of the fraction, we will write the unit and the compound of the element at the end. So it will be like this. To fill the numbers, we would need to calculate the molar mass. In this case, sodium is 23 grams per mole. So we would write the 23 grams and the 1 mole. For iron 3 oxide would be grams down, grams of iron 3 oxide down, moles of iron 3 oxide up, as we have that order in the problem. And to calculate the molar mass, it would be Fe2O3. Fe has a mass number of 56, so as we have 2, we multiply times 2 equals 112 grams per mole. For oxygen, we have 16 grams per mole multiplied times 3, and it will give us 48 grams per mole. Adding these two amounts, we have 160 grams, and this is the number that we are going to write in the fraction. Remember, the number of moles is always going to be 1. Then we need to multiply it as always. In this case, 100 grams of sodium times 1 divided by 23 grams, and we get 4.35 moles of sodium. For iron 3 oxide would be 100 grams times 1 divided by 160, and we would get 0.62. As the last step in here, remember, we need to divide by the coefficients. In this case, sodium divided by 6, that gives us 0.72 moles of sodium. And iron 3 oxide divided by 1, which gives us 0.62 moles of iron 3 oxide. As 0.62 is smaller than the other one, that one is the limiting reactant, and the other one would be the excess. We would continue answering the problem, selecting the 100 grams that correspond to the limiting reactant. We are given grams and we are asked for grams, so we are going to use the procedure of a problem of mass to mass. We need to start with the known, that would be the 100 grams of iron 3 oxide. Then we would write the parentheses with the fraction, and we would end with the grams of iron, that is our unknown. Then we would write inside the parentheses down the grams of iron 3 oxide and up the grams of iron. For iron, it will be 56 times the coefficient, which is 2 in this case, and it is 112. As we already have the molar mass of iron 3 oxide, we just need to check what is the coefficient in case that we need to multiply it. As it is 1, we are going to use it like that, so we write the 160 grams. As a final step of this section, we multiply the 100 grams times 112 divided by the 160, and we get a result of 70 grams of iron. And this will be the result of this section. To end with this problem, we now need to calculate the leftover, that is represented by the mass in excess. That means that we need to calculate the grams of sodium that were actually used, starting with the known, which are the 100 grams of iron 3 oxide, then we write the parentheses with the fraction, and we end with the grams of sodium. To complete the parentheses, we write the grams of iron 3 oxide down and write the grams of sodium in the upper part. Then we need to use the amounts that we already had from the first section, the molar mass of sodium, which was 23, and we multiply it times 6, which is the coefficient that it has, and it gives us 138 grams. Then we use the 160 that we had also from the previous problem, and we used it like that. We already knew that it was times 1. Then we multiply 100 grams times 138 divided by 60, and we have 86.25 grams of sodium. To calculate how much is the leftover, then we need to subtract the original amount that was given, that were the 100 grams of sodium, minus the one that actually reacted, that are the 86.25 grams, and we get a total amount of 13.75 grams of sodium. So this would be our leftover, and that's it. So I hope you got it. Thank you for watching. Bye bye.